Whether you're studying for the OSCP or just passionate about red teaming, Active Directory is something you have to learn. In the OSCP exam, AD makes up 40% of the total score. You'll face 3 Active Directory machines. The first 2 are worth 10 points each, and the final one that is harder is worth 20 points. But why is it so important? Because Active Directory is used by nearly every large organization to manage their networks. Instead of manually configuring each laptop or desktop one by one, the IT department can centrally control devices, users, permissions, and software updates all from one place. That means if you manage to capture even low privilege credentials, you're already inside the network with access to resources most users shouldn't see. Let's walk through a simple example. First, save the machine's IP address to a variable. This makes it easier to reuse in your commands. Next, create a dedicated directory to keep all your notes and files organized in one place. When dealing with an Active Directory machine, your first step should always be enumeration. Enumerating is the process of gathering as much information as possible about the system. We can use Nmap to scan for open ports. Make sure to save the result of the scan by using the O flag and capital N for Nmap to give us a normal format of the result. To save time initially, we ran a simple scan to look at all open ports. So now let's run a detailed scan on the ports that are open for more information. Using the list of open ports we just discovered, we can store all the port numbers in a variable for easier reuse. Next, we'll run a more detailed Nmap scan using additional flags. We'll use the A flag, which enables OS detection, version detection, script scanning, and traceroute. We'll also add the PN flag, which tells Nmap to skip the host discovery step. Just like before, we'll use the P argument to specify the open ports we found, followed by the target IP address. Once the scan is complete, we should be able to view detailed information about the target machine, including DNS domain names and target host name, details that were previously unavailable. Make sure to save the scan results, especially the domain name, as this will be essential for running further scripts against the target machine to gather more additional information. For our next steps, we'll be using a tool called KerbRoot. This tool helps us perform deeper enumeration on the target machine by identifying valid usernames within the Active Directory environment. To run the command, we'll start by using the usernum option, which tells KerbRoot that we're looking for usernames. Next, we'll need to provide the address of the domain controller, both its IP address and its domain name, which we gathered earlier from our Nmap scan. Finally, add in a word list, which you will use to brute force and discover valid accounts. Once completed, you will get a list of valid usernames. As we want to target accounts that are more likely to have higher privilege, look for names like admin or backup. It's usually a great starting point. So store the list of usernames into a file so that we can use an open source library called impacket, which has a number of pen testing Python scripts. Using their getNPUser script, we're going to check if any of these accounts do not require pre-authentication, meaning we can retrieve a hash password of the account without valid credentials to try brute forcing. Start by running the script with Python free, followed by the path to where your IMP packet scripts are located. If you're also in Kali Linux, the path will exactly be the same. Next, add the no pass option, so the script checks for accounts that don't require Kerberos pre-authentication. Then use the user file option to provide the list of usernames we previously gathered from KerbRoot. Finally, specify the target IP address and the domain name. Once executed, the script will test each account and attempt to retrieve an authentication service response. In our case, the account svcadmin does not require pre-authentication, and the script returned a authentication service response. The next step is to identify its hash type. Each Kerberos hash begins with a unique pattern, and on the Hashcat website, we can find the mode number that corresponds to it. We're now ready to run the Hashcat command. Supply the correct mode we just found on the website, then the hash we found from the Python script, and a word list for Hashcat to brute force. After a few seconds, the password will be revealed in plain text at the end of the original hash. Now that we have valid credentials, we can begin enumerating the Active Directory environment for even more information. Using our credentials, we'll start with a tool called SMB client. The first step is to list all available shares on the SMB server. We do this with the L option, followed by the server's IP address and our username. After hitting enter, it will prompt for the password we previously cracked with Hashcat. Once authenticated, SMB client will display all the shares on the server. From here, we can test which shares our account has access to. Simply connect by adding the share name to the IP address, then provide the password again. In our case, we don't have access to the admin share, but when we try backup, we successfully connect and drop into a SMB shell. By running ls, it shows a text file containing backup credentials. Let's download the file with the get command and inspect it locally. The contents appear to be encoded, so let's decode them with the base64 command. Perfect. This reviews the credentials for the backup account. With these new credentials, we can run another tool from IAMPacket called secretdumps.py, which extracts sensitive information like NTLM hashes and Kerberos keys. The script is located in the examples folder, so we run it with python-free secretdumps.py, supplying the domain name, backup account credentials, and the server's IP address. The tool then begins dumping user hashes from the domain. Here's where things get interesting. NTLM hashes can actually be directly used for authentication through an attack known as pass the hash. Since the hash is treated like the password itself, the NTLM hash is enough to log in as that user. So let's copy the NTLM hash for the administrator account. To gain remote access, we'll use Evil WinRM, a tool that provides a Windows shell. We just need the domain IP, username, and supply the NTLM hash. After a few seconds, we're in, and now we're operating as the administrator. From here, we can enumerate the account and search for the challenge flag. Using the gci command, we discover a file called root.txt on the desktop. Opening it reviews the flag and completes the challenge. Thank you all for watching. I hope this gives you a clear introduction to Active Directory exploitation. Bye.